3 copies of your shop have been running this whole time and you never created a single pod yourself. So who did? The answer is the object you will reach for more than any other in Kubernetes, and the one that finally makes your app reachable. You wrote a standing order. That is really what a deployment is, a short document that says keep 3 copies of version 1 of my shop running. You state it once, it stays in force until you change it. And the deployment does not babysit pods itself. It creates a helper called a ReplicaSet, a counter with one job: hold the number at 3. The ReplicaSet makes the pods. Deployment, ReplicaSet, pods, a chain of command. Why the extra layer? Because of versions. Each version of your shop gets its own ReplicaSet. Keep that in your pocket. It is the trick that makes updates safe, and we will use it in a minute. First, the easy win. Friday traffic is coming, so you edit one number. 3 becomes 5. The counter notices the gap and 2 new pods appear. That is scaling, not a migration, not a project. One number. And the loop from episode 2 finally has a name and an address. A pod dies. The ReplicaSet is what notices and replaces it. One honest caveat: it replaces failing pods. It cannot repair a bug in your code. So copies are handled. But keeping 3 copies was the easy half. Here is the hard half. Version 2 is ready, and your customers are inside the shop right now. How do you change the engine while it is running? The obvious move is the wrong one. Stop everything, swap the version, start again. That is a close sign on your shop door, and at 3 in the morning, nobody wants to be the person who hung it there. So Kubernetes does it gradually. You change the image in your deployment to version 2 and a rolling update begins. New pods come up while old ones retire, a little at a time at a controlled rate. Remember the trick in your pocket? Version 2 gets its own ReplicaSet. Now watch both counters. The new one climbs 1, 2, 3. The old one winds down 2, 1, 0. The shop never went dark. One rule makes this safe. A new pod gets customers only after it reports ready. Kubernetes keeps healthy capacity serving while the swap happens, as long as your app is honest about when it is actually ready. Now the bad day. Version 2 ships with a bug and its pods never come ready. The rollout notices and stops climbing, while most of your version 1 copies are still up and still serving customers. And here is the payoff for that middleman. Version 1's ReplicaSet never left. It was parked at 0, a save point. One command, rollout undo, and the counters simply run in reverse. You are back on the old version. One problem remains, and it is the customer's problem. Episode 3 taught us pods are cattle. Every replacement gets a new address. Your pods changed 5 times today. So what number do customers actually call? They call a service. A service is one stable name and address that never changes, standing in front of a group of pods that always do. Customers talk to the door. The door finds whoever is working today. How does the door find them? Not by name. Names are disposable. By label. Every shop pod wears a tag that says app shop. The service selects that tag. A replacement pod is born wearing it, so it is found automatically. And the service reads the same signal the rollout used. Requests are spread across the pods that report ready, and a pod that stops being ready quietly stops receiving customers until it recovers. By default, that door is internal, reachable only inside the cluster. Need the outside world? A node port opens the same port on every node. A load balancer goes further and asks for a real external front door, typically from your cloud provider. Step back and the whole machine is two promises. The deployment keeps the copies right, the right number, the right version. The service keeps the address right. Everything you shipped this episode came from those two. So now your shop scales with one number, updates while customers are inside, falls back to a save point when version 2 goes wrong, and answers at one address the whole time. But notice something, we have been drawing that standing order as a neat little card. In the real world, you write it yourself in a file. Next episode, the file that makes all of this real. See you there.